Yoyo ni aje, hapa ni nworksinc radio podcast episode 24. Yeah. Na hapa niko na mgeni atajiintroduce.
Kwa majina naitwa John Keguro Karaoke. Ni yuko Murang'a.
Nice. John, sasa John ni msomi. Hebu acha tuambie alifanya nini shule.
Okay. Nime graduate na Bachelor of Science in Physics. University of Meru University of Science and Technology. Na ilikuwa second class hapa, hiyo siku ya confirming hiyo stuff.
Kwa hivyo wewe umesoma physics mbaya.
Kwa physics nimeiva. Na physics naipenda. Tuseme nilifanya force yenye ningependa tu kufaulu.
Kwa hivyo you are not in the wrong course.
No, I got the right one.
Awesome. So basically hata juu ya hiyo story, topic yetu unajua leo ni quantum physics.
Quantum physics.
Naona mpaka una smile nimekuja kwa topic yako yenye umesomea na unapenda na unaelewa. Nakali sana.
Karibu ni umesi.
Ilikuwa moto.
Kuna two parts. Kuna the introductory part na the application part of it. So obvious introduction ilikuwa ngumu. Na sasa inaitwa quantum mechanics 1 na quantum mechanics 2.
Okay.
So 1 introduces you to 2.
So usipushika 1, 2 itakunyorosha. So basically tutaanza na definition ya Google. Tunaanza na definition ya Google. Quantum physics wanasema ni field in physics that explains how extremely small objects simultaneously have the characteristic of both particles ni tiny pieces of matter, and waves, a disturbance of variation that transfers energy. In simpler terms, si wote wasomi ni study of matter and energy at the most fundamental level, which are atoms, ndio? Atomic levels, ndio? Wewe unaweza sema ni nini in your own words yenye unaweza sema quantum physics ni nini?
Okay, tuanze to physics. Physics, definition of physics at a very fundamental level. You define it as energy in relation to matter.
Energy in relation to matter. Okay.
So, as physicians or scientists in the field of physics, we try to search what is this energy related to matter. So when we come to the field of quantum physics comes in a way of photons. The people there,
photons na electrons.
No. Photons in form of light.
They're different.
They are different. Now a quantum physicist tries to tell you how much a bright light once strikes into a surface. How does it
dissipate
lightness and at what speed? So quantum comes in form of packets of light. So the photons now you pack them in form of light.
Okay.
Yeah. So now the basic part of it that you are being defined as that a particle can depict both wave presence of
matter and wave.
That is only an aspect of light that happens, and some particles do not depict such aspect.
Okay.
So the physicists who try to discover quantum mechanics, quantum physics aspects of it, are trying to solve an equation. The first and the most fundamental equation in quantum mechanics is the Schrödinger equation.
Ile Schrödinger's cat. Mimi nilisema kitu kama hiyo. Sijui cat inakuwa ndani ya box. Alafu iko na atom, sijui iko na poisonous, iko na poison na nini nyingine?
Na
atom fulani
kwa
hiyo box. Alafu they ask you whether the cat is alive or dead.
That is the aspect of the Schrödinger equation. In fact, that is one of the main examples that our lecturers usually use. So when we come to quantum mechanics, why is it a topic that is like
so challenging, so simple and so hard? Because I understand iko na applications mingi sana. Na even before that, nimeongejua physicist. Mimi kuna physicist nilikuwa napenda Albert Einstein,
father of physics. Alisema physics unaweza kuwa unajua physics lakini usicram physics.
Oh, so how is the cramp?
You don't know points of physics. We always have a frame of reference. So Albert Einstein encouraged all the interviewers on anybody.
Yep.
Don't tell somebody to define it through the neural physics. See how we have a frame of reference.
Or a frame of reference, you can define it as you want, but it will go back to the
Frame of
reference.
and it will fit there. So don't stress a physics. The part of physics was not really a genius, but through consistency.
Yeah. Oh, yeah. Because I understand that in his history, it says it was not good in school. He never used to understand the teacher and what. Even the teacher used to tell him he'll be nothing.
That's true.
And he became one of the biggest
of science. And of the equations he discovered, E is equals to HFC. E maybe ilikuwa hiyo energy yake lakini ni energy. So E is equals to H. H is Planck's constant. F frequency of that. T is the speed of light constant. That is where he came and be the leader of all these speeds that will be, because of latest there is no discovery of something that has a speed much more than the speed of light. So the C there, it is the continuity, the effects that we call the infinity level of something.
Okay. Okay, there's something else you've mentioned, Planck constant. And I had read somewhere, kuna Max Planck.
Max Planck pia alikuwa physicist, alisaidia sana kwa hii topic ya quantum physics. Max Planck alisaidia to define light ikiwa kama in form of an equation of continuity. Na hiyo equation of continuity alidiscover yeye na jamaa anaitwa Hilbert. So kuna Hilbert space equation. Max Planck's equation ya continuity. So alisaidia sana kwa hii field ya
Okay. Hey, that's quite interesting. Sasa kuna kitu inanibombanga kwa hii quantum physics. Kuna a few things nimekuwa me nakuwa too interested in knowledge na kuzoea to learning new things, because at the end of the day you cannot stop learning unless you do not want. However, life will always teach you something new
every day. You thought learning humbles you. Learning keeps you knowing that you don't know everything.
Yes.
So you must keep learning. It will humble you. It will keep you mind. Learning is the time within. Because your time is like learning.
So kuna three things nilisoma. Kuna wave particle duality. Kuna quantum entanglement. Na quantum superposition.
And the first now, the quantum theory that explains that. It tells you the first that you are saying this atom is being held here and the other one is being held here somewhere and no acting of it. It is called quantum mechanical tunneling. That existence of that force that you don't know how to use at all to behave like this and this. You are only there
in different positions, different locations, but they are acting exactly the same.
It is called quantum mechanical tunneling because once, now another example is like that one is for physics. For Kenyan physics, I have a degree that I did not graduate, but in the same.
That is very simple actually.
What is superposition? And I've come here, but the real force here that exists that has pushed you to this proposition this way. You need to explain, but you cannot explain. Quantum mechanically, you don't explain.
You do because there is no explanation yet.
Because for example, if I ask you, that is why quantum mechanics is so interesting. It's hizi unakutanga supermarket inakupandisha hivi na inakushukia escalators. Those things, the engineers who came up with that type of a model of a deal, they were trying to observe zero gravity. So how
because it's going against the gravity.
It is comfortable.
Without issues. Whatever weight you put,
So how did they balance the rates? That is Calota.
Wow.
How did it come to the zero gravity area?
I have no idea. I have no idea.
There is a way, they have the way to build these machines, but they are only quantum mechanics. Yeah. So they observe the zero gravity experiment. That is how it works. So you may not know what causes this or this or this. Once you balance, you attain a zero gravity point of it.
Okay.
Yeah. And it is something observable. So one thing about quantum mechanics is about observable postulates. A postulate is something that helps you, guides you to know an experiment that works.
Yeah.
How can it explain that experiment works? So you have to give certain observables. A very good example, that one I was telling you about our universe.
Just bring
You hold your punch like this. Yes. Surface area. One may ask you, is the surface area of this punch, if I calculate it when it is like this or not?
folded, cringed, or open.
Open.
Yeah.
So, in quantum mechanics, is the folding or
Opening.
it says that we have the same surface area. The difference is the speed you use to open or to close space-time.
Space-time.
So then space-time is an observable postulate that you can observe.
Yeah.
And that is why I was giving an example. When we are young, when something fell down and you picked it.
Oh, yeah. Haijaanguka kitambo. Theater jams hazijasikia.
So it is of sounds that jams of just and you have decided to
Do whatever you want.
it is space time.
And we never used to go sick.
So you left get sick, you just continue it. So the quantum is so exciting. Yeah. And the another aspect that I would like you to understand very well is this duality and
Duality. Wave particle duality.
Yeah. It is the dual nature of a wave. The dual nature of a wave. Yeah. When light was being observed, some light haingepiga kona. Na hapo ndipo particle iko na dual nature. Weight ilivanga hivi sana.
Straight it's always on a straight line.
Diffraction where nini inafanya diffraction, refraction, lakini diffraction ya light kuna venye ina affect. But a wave really exist kwa hizo vitu mbili. Ile ingia shimuki.
Inaweza pass like most waves inaweza pass through like wood, even walls, even most come out tuseme tu wifi. Wifi si ni wave.
Any wave
Na unaweza use inapenya tu
inaweza kutoka igorofa utumie
tumia wifi wenyewe.
So that is a very good aspect that we need to know about physics, about the wave. Because physics, it's all about forces. And all the forces, wherever they act, there is either light acting or a wave. And that is why now the physicists who are in the subject of quantum, mostly they try to show you light can be picked up before a wave. But it is not
a wave. It is not, but we can act like that.
So they give you examples like that one of a cat in a box and an atom in this corner and another one in that corner. They switch one and do this. The principle, the waves, the wave itself, the Schrödinger equation tries to show you the total energy of a wave. Finally, it is about TE, total energy is equal to kinetic energy plus potential energy. Our kinetic energy comes with the Schrödinger equation, the first part of it. Is the one that carries the kinetic energy. The potential energy part of it is the one that comes with the gravitational constant. They have a mass times the gravitational vanes, the variance.
Sina float. Anyway, continue.
It's all about an energy. So the wave that we try to equate in the Schrödinger's equation, we try to look for a wave that is in motion and that one that is discrete. An equation without continuity, and an equation that is discrete without continuity. So you look for a wave, you now find the total energy. Obviously, the total energy some with the probability.
Yeah.
Whether it positive or negative.
Okay. Because now, even when I was reading about this wave particle duality, they were saying it is what you use to measure that determines whether a wave or a particle.
So
What if you measure it using maybe an electromagnetic machine, it will show you it is a wave. When you measure it, a particle, how do you measure a particle?
you will find atoms.
Yeah, you'll find atoms in the light.
In the light, once you split it on a surface, Albert Einstein said, okay, split here light on a certain atom mass.
Itafika mpaka kwa atomic level.
Yeah, atomic level. So that is for the final energy. E is equals to now HFC or at the speed of light to spark out.
Alafu kuna hii quantum entanglement, ndio particles are interconnected regardless of the distance in between them. Any superposition multiple states at the same time until it is measured.
That is why I was talking about our degrees now.
Oh, yeah, that's why you explained.
Yeah.
Sisi wote when we are measured, sisi wote tuko top level kwa kampuni. Lakini how we got there?
We are forcing kufanya ile.
You're the same nilifanya.
Yeah, I think the serious aspect very clear. The quantum root.
Awesome. So, nataka tuongee story ya applications, some applications. Ndio to see hii topic, what I feel is this topic is quite deep.
It's very deep. In fact, haijamaliza kudiscover it. Ile kitabu kienda library ka quantum mechanics ni kadogo. Hadi lecturers zile notes wanatubele. Unakuta the notes with the lecturer are very different from this lecturer to this lecturer. Pia kwenye disability bila for the weeks yake.
Oh, so it is venye tu umesema ni lazima kuwe tu na reference. Physics ni wewe venye tu umeona ama venye umeunderstand. Reference sasa ndio
tuende sasa kwa kitabu. Schrödinger equation inasema this is equals to this. What is this? Hii sigma unaniwekea hapa mbele equation inataka tunataka toto ina.
So but it's good at least unajua maybe hata some of our listeners maybe wanataka kujua ama wanadhani hawana mtu anaweza ongea about quantum or something, but you see if you get this opportunity where we give like this topic na tuiweke hapo kwa mtandao, people can ask questions, they can even approach me and we can talk, can even have a deeper conversation, because venye tu umesema it has not been discovered in quotes as in
yani in fact mtu akitoka tu na an aspect tuseme of light flipping utoke na kitu project inaweza toa flipping flipping energy inaweza depict example ya ile tuko tunasema charger wireless vitu kama hizo
sasa. Yeah.
So hizo vitu ni quantum, kuna pahali light inatumika. Hii kitu iPhone ukiekelea charger hapa juu ina charge na uko ndani. Kuna pahali hiyo light inazunguka.
Yes. Okay, so applications sasa nilikuwa very interested hapa hivi ati simu yangu iko na inatumia quantum physics. Kutoka kwa semiconductors na hizo electrons zenye ziko kwa ndani. Yani zote from that simu yangu ni inatumia quantum physics.
Inatumia unaona aspect mzuri sana na one of the best discoveries physicists walifanya kwa history ni about optical fibers. Optical fibers ni physics yenye tunatumia light to reflect light. Through the reaction na speed ya reflection inatoa a certain form of a wave. Hiyo wave ndio sasa sana tunatumia kama kwa internet
na ndio inatumiwa inaenda ina shift kutoka light inaingia paka kwa physical na inakuwa ones and zeros na sasa inaingia paka kwa router ina modulate na demodulate, alafu inaingia sasa paka kwa simu yako kwa wifi
uje uko ndani
bro. No, something else about optical fibers. Most of them ziko kwa sea, under the sea. zinakoga zimepitia kwa Indian Ocean hivi. Hata I think like a week ago there were some multiple fiber cuts. And they affected the internet quite a lot in Kenya. Yes. In mpaka South Africa. And that is very interesting. Yani imetoka all the way huko. And then turudi sasa paka mwisho kwa simu yangu nikifanya speed test iko na kitu inaitwa ms milliseconds. How much time hiyo data inadimodiwa imetoka all the way kwa server ya Google, which is let's say even in Amsterdam. Come all the way to Murang'a to my phone na inatumia 15 milliseconds. So that is
a very high speed, a quantum. So that's quantum speed.
So that's a quantum speed.
In a quantum speed, ama quantum. Quantum inajaribu kuturudisha ile duniani. Huoni kitu inafanyika. You don't see.
You can.
So the speed of light. Yeah. Quantum ndio maana tunataka. They deal most like in your light equation. Hiyo equation. Utaifanya ikiwa Hilbert space, ikiwa wakina Max Planck, akina Schrödinger equations. Hiyo Schrödinger ataku. He explains to you now the equations, the continuity of this light. So how it comes to your phone is that principle reflection.
Yeah, that's crazy.
What? Light and reflecting light in the semiconductor. So
none of it travels through.
Hizi semiconductors ziko kwa simu zinakuanga fibers.
Yeah.
Fiber optics.
Yes.
So zenyewe ndizo zina reflecting. Okay. I was asking another person. Mbona mmea ikimea kwa nyumba inameanga na storm kwa hii? It's very nice. Ni juu light haifiki enough. Na hiyo mmea inahitaji light na umea kumea. So hiyo mmea inajireflecting ikireflect.
Hata naonanga saa zingine mmea inafuatanga tu lights. Unapata imejikundu inaenda mpaka karibu na dirisha.
So inatafuta ile light. Na sasa mbona inamea ikiwa white na inafaa imea ikiwa green? White color ndio hiyo light yote. White.
Oh yes. Yeah.
White color ukiflit ndio inatoa rainbow ya.
Yes, rainbow, yes.
So hii mmea inahitaji light fulani. So ikiona huko kote kuna giza na kuna light kama kale ina reflect kana reflect back inasafiri light hiyo ndio inapatanga light.
Seriously?
Yes.
Wow, okay.
Na mmea ingine next nayo sasa itagrow haraka juu zita reflect yana iko white. Okay, kama reflection lakini kuna
refraction najua ni ile bending of light.
So the reflection refraction zitafanyika kwa hiyo mmea ndio iende hivi hadi inaweza tokea ukifanya sasa light iko.
Wow. Hey, that is deep, man.
When we talk of light, hadi tusikie kwa simu yako kuna vitu quantum. Kwa simu yako, okay, for example, Mercury. Mercury is the heaviest thing in CF4. So Mercury, nzungu anashinyanga kwenye network. Kwa simu yako kuna Mercury. So utoto Mercury tuote tunahitaji kitu kingine. Mercury ukimeza itakaa kama
Mercury. Hata ukimwaga mahali na bakingi tu ikiwa blob.
So like simu yako the aspect of Mercury ikikuwa liquid yenye haitoi character the same na liquid vingine. Kana hitajika kapisi kadogo hivi kakue kameko kwa hizi optical fiber. Na sensing na sensitivity yote na work sasa kutoka hapo.
Oh, okay. So then, hapa inasema quantum mechanics principle control the flow of electrons in devices, allowing them to process information. MRI, imaging na magnification. Hizi ni applications, sasa ni ile ati ukiingia kwa MRI, hiyo MRI sinakuwa that circle like this. So it is able to see atoms in all your body, inside all your body. Yeah. By refraction.
Really?
Ni reflection ama ni refraction ama ni both of them? Reflection.
Yeah.
So it
wave inakuhit.
Also the wave inakuhit alafu sasa
so iko bisha huko kwa hiyo bulb sasa.
So MRI kuna receiver na transmitter. So ina send hizo waves hizo alafu zina
reflect hiyo image.
Ikipata, so if whatever ikipata, let's say something that is hard, maybe like a bone, inapita flesh inaona ni kadogo, inapata bone, pia bone inaweza ipita kidogo depending na ile level umega ya kuona.
Say hapo napo ni frequency sasa inaingilianga hapo. Just like we said, physics is ni energy and radiation to matter. Now energy now hapa hivi ni tuseme ni frequency. Frequency ile tunaweka kwa ile machine. Ile matter ni mwili yako sasa. Now when you change the frequency of energy, even the wavelength changes.
Okay.
The wavelength example ni like our radio here.
Yes.
So kuna kitu inaendelea hapa, kuna after saying
my hair
na kuna ile waves.
Yes. So frequency na wavelength, yes. Because what I understand that frequency ni how wide or how small the wave iko.
Ila bidia
the speed
and ikiwa half full the
okay.
So kwa history yetu on the right hizo machines, in fact many doctors are using when you see a doctor, that doctor knows physics upside down. They use that as only that they don't like the mathematical aspect of but everything else, all the machines, all those doctors, surgeons, they know light.
So at the end of the day, it's all physics.
You wait. So the speed of light hapa hivi hiyo ila kuona na uko ndani ndio inamata sana. Na sana nakupa hadi ilibidi kumedefiniwa in different fonts. Kuna alpha, beta na gamma ray. So when they come in form of rays, they are form filled. Kuna ile machine hadi ukipiwa x-ray unaona kwa hospitali kama machine kama gas reader. Akandiko kama machine kana pump ile kitu inatoka ikiwa form of wave. Na ile kitu itoke tuseme x-ray. Hiyo wave kuna ile strength iko
nayo kuna mali inafika, iko na limitations zake bado, na bado kuna nini zake, pros na cons zake, yani in fact
x-rays. Na ukitoka tuseme kuna alpha decay, kuna beta decay na gamma decay. So pia kwa quantum mechanics hizi equations zote tulikuwa unazichambua. Unachambua beta ikiwa beta particle inapatikana pale, ama ikiwa ni gamma particle, au equations au strength wake na probability yake kufanyika.
Damn, that's quite interesting. Alafu kuna vitu kama electron microscope. Electron microscope inaona mpaka crystal inaona mpaka, yani ikiona tuseme hata hiyo mercury kiangalia inaona mpaka the crystal structure. Zile vitu zinakongana tu circles na lines. Sindio? Inakutolea sasa unaiona hapo hivyo.
Ni application moja ya quantum.
Alafu kuna GPS. Unajua sasa GPS how they use quantum physics for this is using the atomic clock. Because for GPS to work, time lazima ikuwe inasemaje? Totally accurate. Because it's 3 satellites that look semeka simu yako inatuma waves, ndio? So the satellites zina triangulate.
That's true.
Ni tatu. Na sasa kama time iko off in any of them, you will get the wrong position.
So kuna telescopes zinatumika huko kwa hizo
satellites. Hapa hata si telescope. Hapa hata si telescope. Hapa ni satellite. Telescope ni zile zenye unaweza kuview. Hizo ndio wanatumia kuona zile stars kuna huko
mbali sana.
Na bado zinatumika. Bado ni still an application or in quantum physics, because ndio uweze kuona na huko lazima venye tu umesema speed of light.
The speed of light. True.
So for GPS, that's the thing. To get your accurate location, if the time is not equal, ukichukua hata sasa hivi ukiangalia time yako na time yangu, kazi inatumia battery, most of the time zitakuwa the same. Lakini tukiangalia simu yako na simu yangu zitakuwa the same, because they basically they're always communicating with the cell tower and the satellites as well. So when they're accurate, you get an accurate position through triangulation. Kuna hii historia ya quantum computing. Nimesikia story
Computing, yeah. Pia hiyo umesema some hizo stuff zenye ziko mbali, yeah. Nini so quantum computing ndio sasa inakwambia haijamalizika.
hata ndio inaanza actually. They are starting now.
Everybody outside there anatusikiza ama tu wako interested na physics.
Yeah.
Na hiyo aspect ya quantum computing inakuja.
Yes.
Hiyo aspect ndio itakula. Hiyo itabadilisha dunia.
Hiyo sasa hata nilikuwa nasema if they put quantum computing in AI, unajua that's it. Hapo ndio singularity inakuja.
So pahali tuna head we expect kila kitu itakuwa almost wireless.
Yeah,
Everything tutakuwa tunatumia light sasa.
Yeah. So what is happening is a multidimensional discipline of computer science, physics, and maths.
Yeah.
So basically, in computing, we always have 1 and 0s,
Binary.
which are called bits. Yeah.
Bits.
Yes. In quantum computing, they are called qubits because each bit can be in 2 states. Tunakumbuka tuliongea hapo story ya states.
Yeah.
Sasa si hizi ni bits mbili kwa computing 0-1. Sasa kwa quantum computing kuna qubits. Hiyo 1 bado inaweza kuwa 1 na mwingine. Na hii 0 inaweza kuwa 0 na mwingine. So it is much faster in processing information. Sai hata kuna kitu inaitwa brute force in cyber security. Brute force ni ile unajaribu guess password ya msee using unajaribu yani brute force ni kujaribu all capable
Codes. Nini patterns?
Patterns ama
Zingiana.
0-1-0 hata si 0-1 kama ABBB, yani kutafuta
Pattern ya mtu.
hata si pattern ya mtu. Unachika password.
Yes.
Password tuseme hii password umesema umeandika tukaa password. Ndio get hii password, brute force ni itaanza first haijui hata uko na letters ngapi. So itaanza na the first section of the P.
The P.
Itaanza A, B, C, D, E, Z, alafu ikipata ipate P ina stop. Alafu inaenda kwa the next one.
Yeah.
Hivyo. So it takes a really long time ama you have to have a very powerful computer for it to do a 12 character. Unaget ni tu
kuibuild.
Kwa hivyo kama tuseme tutumia 26 characters in the alphabet and the password is 6 characters long. Hivyo ni 6 to the power of 26 possibilities. Sindio? You understand?
Yeah, probability.
Yeah?
Ikuwe hii side ama hii side.
Yes.
Ama ikiwa hii side yetu.
Yeah. So if you can imagine how long it will take just a normal computer to do that. Now this is a quantum computer. So it can
produce
it can write so many codes at the same time.
Na speed ingine ni ya second.
Na venye tu umesema at the end of the day ni speed of light.
The speed of light. Ile speed ya kuflip hivi.
Yeah. So
ni flipping.
Na bado inatumika hata kwa encryption, ku-encrypt vitu. Uki-encrypt kitu na quantum, ni ngumu msee kuibreak na machine tu ya kawaida. Lazima utafute another quantum machine ndio uweze kufanya hivyo. Hii topic iko very interesting, very wide, and kitu napenda ni ati napenda kuongea juu vitu mimi sielewi, and nimeona uko very vast in this information, and I know it's not easy to find someone to talk to about this information. Ngumu sema
ile lecturer mimi alinifunza hizi vitu. Yeye mwenyewe alikuwa ametoka UON. Though alikuwa ametoka Spain. So like alikuwa ni wale ni doctorate. So kwa UON na kwa majuu. So interesting part of it alituletea people from Spain.
Okay.
Na hao watu wanafanya kwa observatory ya Spain. Those in the astronomical headquarters of observatory ya Spain. So watu mostly they use computers. It's all about computing. So wanatumia hizo computers kusikiza
sounds in out of space. Kusikiza vitu na kuangalia hata bado.
Ikiwa vitu unique sana, wako curious about our space and our physics. And they are ready to develop it in form of programming. Na sana bado wajue awareness.
Yes.
Yeah.
So mina hope I think we'll stop there because hatuwezi tutahave kujistop juu tutaweza endelea mpaka because hata hatujaguza
Hiyo ni topic moja. Tujaguza kina nuclear radiation, astronomy, physics.
But we'll ask our listeners if they'd like this topic to listen to it. Ama kama kuna mtu mwingine mwenye out there na anapenda physics, si anaweza come to have a discussion. As you said, learning is continuous.
Learning is lifetime.
Is a lifetime, and you have to accept that. And asante sana for coming through. We've had a very good topic. And kama kawaida lazima tujibig up. Sisi ni nworksinc radio podcast. Tuko na radio hapo kwa mtandao. Ukitaka kusikiza unaandika tu bit.ly/nwks radio. The R is capital. Asanteni sana.